Hey there, it's Katie with TutorPUG, and I'm going to do a little session on Calc 2 method of least squares. So in honor of this spectacularly beautiful day and the Memorial Marathon that's happening, I decided to use an example that linked the temperature outdoors with how long it takes to finish a 10K. I know that at the marathon they're doing half marathon and full marathon, not a 10K, but this was the best I could come up with on the fly. So what you're doing with method of least squares is you are going to take information that you're given in a table, and you are basically going to find the equation of a line using a method of least squares and some calculus to find the equation of the line that describes that data. You're doing what the calculator does when you put stuff into L1 and L2 and do linreg, stat calc linreg. So it's going to take a little intestinal fortitude on this. You will need to remember this particular formula, or I guess it's a formula. You'll need to apply that, and that is something that you will need to remember because that is the construct for the whole entire problem. So let's get started. What I'm going to do is, this is going to use partial derivatives. So I am going to create a multiple variable function using this formula and these data. I'm going to take the first partials of that function, set them equal to 0, solve for the variables, create a complete model. So the first thing I'm going to do is create S of M and B. And you'll always want to use the letter capital S, little m, little b. S for squares, M for slope, B for y-intercept. So the way it works is, for every single point, I am going to do mx, so 70 times x, no. So for each point, I am going to do m times x, so the value of x for that particular point, plus b, the letter b, minus the y value for that point, quantity squared. And I do that for every single point as I move along. So here, I'm going to do 70m plus b minus the y coordinate, quantity squared. And then I move to this next one. I will sum these, and I'm going to do the same exact structure. 79m plus b minus 51 quantity squared. And then lastly, 85m plus b minus 63 quantity squared. So that is the first step, is to create the entire function S of m and b, and it uses this formula. Now I'm going to go to what I call step 2. I'm going to find the first partial with respect to m and the first partial with respect to b. Real quick, in case nobody has ever met Piper, this is her. She just snuck upstairs and is about to get in big trouble, but she's bored with all this because she actually can do calculus in her head and thinks that she's all that, don't you? Yeah. Okay, you go be good. So I'm going to find the first partial with respect to m first, and I'll write that up here. And notice how, we're going back to first partials, each of these items in parentheses has an m. So I am going to, and they're all squared, so I am going to have to use the chain rule. It's easy chain rule. It's going to work the same way every single time. Don't get nervous, but it is the chain rule. So the first thing I'm going to do is I am going to keep the guts exactly the same, the two drops and flops, and then I'm going to multiply by the derivative of the inside with respect to m, which is just 70. Over here, same game. 2 times 79m plus b minus 51 times 79. And lastly, 285m plus b minus 63 times 85. Now what I like to do is, instead of taking s sub m and then s sub b immediately, I find s sub m, completely simplify, then I find s sub b and completely simplify. So I'm going to clean each one of these up because I want them to I want to combine all my like terms. So here, be careful, I've got a 2 in the front and a 70 in the back. So I'm going to do 2 times 70, which is 140. Distribute that all the way through. These are just long, and the algebra is very simple. Just pay attention to your numbers. So this will turn into 140 times 70, so that's 9800m plus 140b minus 6440 over here. 2 times 79 is 158. Distribute that through. 12482m. And then lastly, 2 times 85. 170 will get distributed. And now what I'll do is I'm going to come back in true 8th grade Algebra 1 fashion and combine my like terms. And I will come through and underline them just so I keep things straight. So all of my M's I underline once, all of my B's I underline twice, and then my coefficients just kind of sit there. So my S sub M is going to be 9800 plus 12482 plus 14450 is 36732M. My B's, 140 plus 158 plus 170. And then my remaining numbers are that. So I'm going to take that and just write him over here to give myself some room, and I'm going to set it equal to 0. We'll get to that in just a second, but I've got S sub M. We're going to tuck him to the side. So now it's B's turn. I derived S sub M. I got him all cleaned up. Now I'm going to come back to the original, and I'm going to derive it with respect to B. Okay, still have to use the chain rule, but it's going to be a little bit cleaner because on every single one, B's coefficient is just 1 every time. So I don't have to worry about deriving the inside per se. You can write the 1 if you want, but you don't have to. So this will be there's my partial derivative with respect to B. Now I'll clean that up. So I went and I distributed my 2's on the outside of the parentheses and got this all stretched out. And then I'm going to combine my like terms again. So I will do my underline trick to keep me straight on that. And that gives me this, 468M plus 6B minus 320. So I'm going to write that down here. S sub B is 468M plus 6B minus 320. So I have my first partial derivatives, and I am going to, just like in the last unit, set them each equal to 0 and solve for M and B. Trying to find the equation of a line, y equals mx plus b. So now I have a situation where I can build the matrix. All of my variables, all of my m's, all of my b's are to the first power in both equations. No m's and b's are multiplied together, so I can use the matrix. Make sure when you construct your matrix in the calculator, if you choose to do that, that you put it in the order m first, then b, then the equal sign, and lastly the final number. So my first line would be 36732 positive 468, and this would get moved to the other side, so he's on the correct side of the equal sign. The next one is 468 positive 6 positive 320. And now I will go to the matrix in the calculator, and I have a 2 by 3 matrix. So when I do that, I put this into my matrix menu. It's a 2 by 3 matrix. I'm still going to perform RREF, reduced row echelon form, and that gives me a value of M of 1.088 and a value of B negative 31.509. I'm rounding to 3 because I'm going to create a model, and model coefficients are rounded to 3. So my final answer, what all of this was leading up to, my very final answer to this entire problem is f of x equals 1.088x minus 31.509 gives the time to finish a 10K in minutes when X is the temperature in degrees Fahrenheit. The hotter it gets, the harder it is on the body to run, at least it is for me. So I'm going to go a lot faster when it's cooler or colder than I am when it's hotter. I just kind of stop and lay down on the side of the road and wait for the ambulance. So your final answer is the equation of a line. This is what you were working for. You have to show all of that work to get this credit. One thing you can do, which is really nice, however, is to check your answer and see if you did it correctly. Go to Stat, Edit, enter your inputs into L1, your outputs into L2, and do Stat Calc Lin Reg. Run the equation of a line, and it will give you, hopefully if you've done your math correctly, it will give you those values for M and B based on this data. So give that a try. It's a great way to check yourself. And again, absolutely spectacular set of work, and happy mathing.